Why do cats always land on their feet? The science is stranger than you think. A cat falls upside down. For a split second, it looks impossible. Its back faces the ground, its paws point towards the sky. There's nothing to push against, no wall, no branch, just empty air. And yet, before it reaches the ground, the cat twists gracefully and lands on all 4 feet. It almost looks like it has cheated the laws of physics. But the truth is even more incredible. For centuries, people have watched cats perform this astonishing maneuver. Some believed it was pure instinct. Others thought the tail acted like a propeller, spinning the body around in mid-air. It sounds convincing, except it isn't true. Cats missing part or even all of their tail can still land on their feet. The tail helps with balance in many situations, but it isn't what flips the cat during a fall. So what does? That's where the mystery begins. The problem wasn't that scientists couldn't see cats landing safely. They could. The problem was that physics seemed to say it shouldn't be possible. One of the most important laws of motion says that if nothing applies a twisting force, an object can't simply start rotating. Imagine dropping a book upside down. It stays upside down. It doesn't suddenly decide to flip over halfway to the floor. A falling cat should behave the same way, but it clearly doesn't. For years, this looked like a contradiction. Then, in the late 1800s, French scientist Étienne Jules Marey used one of the world's earliest high-speed cameras to capture a falling cat frame by frame. The photographs revealed something no one had ever seen before. The cat wasn't rotating like a solid object. It was changing its shape while falling. That tiny detail solved one of nature's most famous mysteries. Unlike most animals, a cat has an extraordinarily flexible spine. Instead of moving as one rigid body, it divides itself into 2. The front half rotates one way, the back half rotates the other. Think about a figure skater. When the skater pulls their arms in, they spin faster. Stretch the arms out, and the spin slows down. Cats use the same idea, but with their entire body. As they fall, they pull in one pair of legs while stretching out the other. This changes how easily each half of the body can rotate. The front twists quickly, the rear twists more slowly. Because the 2 halves rotate in opposite directions, the overall motion still obeys the laws of physics. Nothing magical is happening. The cat isn't defeating physics, it's using physics with extraordinary precision. Once the front paws point downward, the cat changes position again. Now the rear half swings into place. In less than a second, the entire body is perfectly aligned for landing. But another mystery remains. How does the cat know which way is down so quickly? The answer is hidden inside its ears. Deep within each ear is a tiny balance system called the vestibular system. You can think of it as the body's built-in orientation sensor. Tiny fluid-filled canals detect even the smallest movement of the head. As the fluid shifts, microscopic sensors instantly tell the brain how the body is positioned. The moment a cat begins to fall, this system goes to work. Its head turns first, the body follows. The entire sequence happens automatically, without conscious thought. The cat isn't calculating angles or making decisions. The righting reflex is as automatic as blinking when something flies towards your face. Once it begins, every movement follows almost perfectly. Scientists are still discovering new details about this remarkable process. Recent biomechanical studies suggest that the upper part of a cat's spine is even more flexible than the lower part. That means the front of the body can begin rotating before the rear catches up, making the maneuver even smoother than earlier models suggested. It's a small discovery, but it helps explain why cats perform this movement with such incredible speed and accuracy. Of course, this amazing ability has also inspired plenty of myths. Perhaps the biggest is that cats always survive falls. They don't. Landing feet first greatly reduces the risk of injury, but it doesn't eliminate it. Height, the surface below, the cat's health, and many other factors all influence the outcome. Another surprising fact is that very short falls can sometimes be especially dangerous. That sounds backwards. Shouldn't a shorter fall always be safer? Not necessarily. The righting reflex needs time. If a cat falls only a short distance, it may not have enough time to complete the rotation before reaching the ground. A slightly longer fall gives the body more time to orient itself. That doesn't make high falls safe. It simply shows that even one of nature's most impressive reflexes has limits. Kittens reveal those limits better than anyone. Newborn kittens can't perform this maneuver. The righting reflex develops gradually over the first few weeks of life as their nervous system, muscles, and coordination mature. Only then do they begin landing with the confidence we associate with adult cats. That tells us something important. It's not magic, it's biology. A complex system refined through development and millions of years of evolution. But why would evolution create such an extraordinary ability in the first place? The answer probably begins in the trees. The ancestors of modern cats spent much of their lives climbing, hunting, and moving through branches high above the ground. For an animal living off the ground, every slip could be fatal. Those better at recovering during a fall were simply more likely to survive and pass on their genes. Over countless generations, natural selection shaped bodies that became increasingly flexible, balanced, and agile. The righting reflex may not even have evolved specifically for falling. The same flexible spine that allows a cat to twist in mid-air also makes it a better climber, hunter, and jumper. Falling safely may simply be one remarkable bonus of a body already optimized for movement. And humans have been paying close attention. Engineers designing agile robots study cats to understand how machines might recover if they lose balance in mid-air. The goal isn't to ignore the laws of physics, it's to use those laws as elegantly as nature already does. That's what makes the falling cat so remarkable. It doesn't reveal a flaw in physics, it reveals the extraordinary power of evolution. Every twist, every movement, every perfectly timed adjustment is the result of millions of years of biological engineering working in complete harmony with the rules of the universe. The next time you watch a cat leap onto a fence or land effortlessly after a jump, remember that you're not seeing luck, instinct alone, or magic. You're watching one of nature's most elegant solutions to a problem that once seemed impossible. A masterpiece of evolution solving a physics puzzle in less than a single second.